it turned out that the DiffusionGemma running really well on Mac. Do you know how fast it can run? Let me show you step by step on how to install the software and how to download the model and how to run it. I will also provide a tip on how to do some tuning to make it running even faster on your Mac. Stay with me. So in this video, we'll look at one of the latest upgrade for the Gemma 4 model. This is called DiffusionGemma, which claims to running it really fast because it has a different running mechanisms, which is based on the diffusion. Here's a quick look comparing the diffusion-based language model versus the autoregressive large language model. On the left side, for the diffusion one, we see that during one pass, it generated multiple tokens. However, for the traditional autoregressive model, it generates one token at a time. So it can give at least 2 to 4 times faster generating speed. So we'll be looking at it to try it on the Mac on Apple Silicon. So in this machine, which is M3 Max, will be install it via the llama.cpp. This is the command we will be using to build the llama.cpp because right now it's still in a branch, so you will need to check out the specific branch on that. For Mac, you will need to turn the DGGML CUDA to off, so that will be using the CPU, which default to Apple Silicon's GPU. And then I think it just follow that, you should be able to build it. So for the model checkpoints, we will use the onslows quantized version. So there are multiple versions. You can try them. I think if you want a better quality, you can try the highest one. But if you want to save some VRAM, you go with the 4-bit. So that's also the one I'm gonna use today. Once I have those ready, I will be able to run it. So one thing I want to mention is that there is a flag called diffusion visual. So this one can give you some visualization of the real-time generating of that. So because the diffusion is a little bit different from the autoregressive, with that, I will press enter. And let's pay attention to the RAM, to the GPU, and the CPU. So we see the RAM started a spike here from around 42 to 87%. That's because of the size of the model. So the size of the model is about 17 gigabytes. And we see the GPU is right now here. And let's try with some prompt. And press enter. Let's pay attention to the GPU at the same time. Okay, so on the left, you see that it's quite different from the traditional large language model, right? The large language model is from left to right, but for this diffusion model, you see that some of the words are constantly changing, so that's because of the denoising steps. So as for the GPU, we see that it goes up to about 90% or even 95% here. So that means the Apple Silicon is using the GPU to do the denoising steps. And for the throughput, we see it generated the text at 31 tokens per second. So that's pretty fast, 31 tokens per second for the M3 Max chip. Great. So let's try with some longer prompt. Why is sky blue? Press enter. Right, you see that there's a large block of text. Some of them are changing, some of them are stable. And watching at the GPU doing the work, it just stays at about 98%. So the result is out. Each time it's generating a 256 token canvas, and then the total final output at a speed of 28 tokens per second. Because of the smaller size of the quantized version, so it really works great on Apple Silicon. Another thing I want to mention is that for this model, there are several parameters that you may able to tune to enable to make it running faster. One of them is the number of max steps. The max, if it's 48 compared to 24, 24 can give it a better speed up. So then there is a temperature for the max and also for the minimum. You can try to tune them to see which one give you better speed. So we see that. Pay attention to the GPU and the RAM. The RAM loading is very fast to about 88%. So now we can ask a question. What model are you? Press enter. So we see it start the diffusing steps. So pretty fast. I think it only take about 5 steps to be able to generate the output. So it depends on the prompt. So if your prompt is more complicated, it will take more steps. If it's easier, right? So probably 1 or 2 or 3 will be able to generate the final output. So in this case, we generated it at 75 tokens per second. So that's really fast. If we give it a more complicated one. So why is the sky blue? Press enter. So this time it will be more time consuming, right? Because there will be more reasoning involved. And looking at the GPU and also the RAM, sometimes it even can start from the beginning of the game. And eventually it gives us the output. So let's take a quick look at it. So it has some thinking part is here. And also there is eventual results here. So the output give us at 30.8 tokens per second. So it really depends on the prompt. But overall, if you want to do a tune for that, you can pay attention to this flag. To conclude today's video, it's a very smooth experience using llama.cpp to run the DiffusionGemma. Please post your generating numbers on the comments. I will also looking into using the MLX to run the DiffusionGemma. So please stay tuned. Thank you for watching. Please give it a thumb up and share it. Please subscribe to the channel for future content. Thank you for your support. Goodbye.